So the problem states, prove that the composition of two linear functions is linear. In other words, we have this transformation t, which is linear, and we have this transformation s, which is linear, and we want to prove that the composition of the two is also linear. So we'll start off by proving, well, you need to prove two things in order to have a transformation be linear. It has to be additive, and it has to be homogeneous. So all that additive means is if you take this is the composition of the two functions st. If you take an input like a plus b and you add two vectors, you're going to get out the same thing as if you did them separately. So in order to prove this, we'll start off by plugging in a and b, and then we can take this one step further by saying s of t of a is equal to t of b, added to t of b. So we're just basically distributing this among the t's, and then we can go further with this by saying the same thing for s. And then this is the definition of a composition. So if we represent the composition by st, we can rewrite this as st of a plus st of b, and that is the same thing as what we were trying to prove. So the transformation is indeed additive. Next, we have to prove that it's homogeneous. All that homogeneous means is that you can take some constant, we'll call it c, and you can multiply the input by the constant, and you would get out the same thing as if you had multiplied the transformation as a whole by that constant. So we'll start off, it looks like this. So we'll start off by plugging in c into our input, and this is the equivalent of saying you're multiplying the input, distributing t into the function. You're just plugging in t into s, and then we will take out the c, and then since this is just multiplying by a constant again, we can take out one step further, and this again is the definition of a composition of two transformations, so we can rewrite this as st of v. V is some vector, and we have just proven that it is homogeneous. So we can now state that it's linear.